Okay, we left off, and you had a couple Wilbur questions about this situation right here. We want to focus on these quantities. An input quantity of a measure of an angle swept counterclockwise from the 3 o'clock, and we'll do radians, but you can do any angle measure that you want. Okay, and this is our standard angle. This is where we're going to live for the next month, okay? And so starting next week, you'll be writing out these quantities specifically because they're so crucially important, okay? The measure of the angle swept counterclockwise from the 3 o'clock position. So the bug there's the bug in the 3 o'clock position. We imagine the fan starting to rotate counterclockwise, and we're going to think about the angle through which the bug rotates counterclockwise from the 3 o'clock position. This is a standard thing, so we want to really understand that and be able to. So the measure of the angle swept counterclockwise from the 3 o'clock position, and then we want to track as that angle changes. We want to track the vertical distance above the horizontal diameter as a fraction of the radius length. As a fraction of the radius length. Okay, so that quantity, that vertical distance above the horizontal diameter, when the bug is here, when the angle is 0, the measure of the angle, what is the vertical distance above the horizontal diameter? What's the value of it? Someone said 0. Do you agree with that? Yes, it's 0. It's because this is the horizontal diameter right here. Okay, what's the greatest value that the vertical distance above the horizontal diameter as a fraction of the radius length could take on? What's its greatest value? Someone is saying 1. What do you think? And where does it take on the greatest value of 1? For what angle? For what angle does the output, the vertical distance, take on its greatest value equal to 1? For what angle? 90 degrees, or we're going to practice radians. How many radians of angle measure is that? Pi over 2, right? Halfway around the circle is pi radians. So to the top of the circle. So that output has its greatest value when the bug is at the top, or when the fan has swept pi over 2 radians. When does that output value have its least value, and what is that least value? When does it have its least value, and what is the least value? How low can you go? Right? Right here, right? What's the value of the vertical distance above the horizontal diameter here? 1? So we're gonna specifically say that this output is the vertical distance above horizontal diameter. So when we're below, negative, right? So by saying above, then we know that if it's positive, we're truly above, and if it's negative, then we're below. So value of that output quantity right here. What is it? No, the output, the vertical distance above the horizontal diameter as a fraction of the radius length. What is that value right there? Did you say something? No? Who said? What is it? We're tracking the vertical distance above the horizontal diameter as a fraction of the radius length. And we're looking for it when it has its least value. When it has the least value. I'm giving you a big hint. Here is where it has its least value. What is that least value? 1.55 pi. Agree with that?
No, pi.
1.55 pi. 1.5 pi. 1.5 pi is the least value of the vertical distance above the horizontal diameter. Agree? Who said no?
Negative.
Negative what?
1.5 pi.
Negative 1.5 pi. Agree with that? Still saying no. Who said no? It's not right. We have to get our quantities straight. there are two quantities in play. There's the angle swept counterclockwise from the 3 o'clock position, and then there's the vertical distance measured in fraction of a radius length. So I'm asking about the vertical distance as fraction of a radius length. Is it 1.5 or negative 1.5 pi here? You're confusing it with the angle measure. The angle measure is 1.5 pi here. But as a fraction of the radius, how many radius lengths is it now below the vertical diameter? It's 1, but the quantity says above. So the value of this quantity is negative 1. Negative 1 radius lengths above the horizontal diameter. So make sure you have your quantity straight. The input, yes, is angle measure, angle measure. But I was asking about vertical distance. The vertical distance, this is 1 radius length from here to here. That's 1 radius length. Or as a fraction of a radius, it's 1, right? But since we said below, then that value of that quantity would be negative 1. Does it make sense? Okay, so for an input of 1.5 pi, meaning 3/4 of a full rotation, the output, according to our quantities that we're talking about, is negative 1. Does it make sense? Okay, so we want to track a little more. So that's just some warm-up questions to get the feel of this. Well, we want to track this a little more closely, like you did in your homework. So we want to look at the changes. So as the input angle changes from 0 to pi over 2, does that output vertical distance increase or decrease? Increases from what to what? 0 to 1, right? It starts at 0 and then ends up 1 full radius length above the vertical diameter. What about the changes, right? So this is our covariational reasoning. What about the changes in vertical distance? So look, here's the first change. Here's the second change, and I'm showing it, I'm highlighting the vertical changes over here to the right of the wheel. So here's the first change, here's the second change, third change, and fourth change. Are the changes in vertical height increasing or decreasing or staying the same? They're getting shorter, right? They're decreasing. So we have an increasing quantity, the vertical height is increasing, but the changes are decreasing. And so if we start at 0 and end up at 1, with increasing, with decreasing changes, what will that look like? Well, we're increasing, but each change is less than the one before. So that's our decreasing changes means a decreasing rate of change, and then we get a concave down graph, concave down. Okay? In the second quadrant, so I want you, for each of the 3 remaining quadrants, I want you to answer, is V increasing or decreasing? And then, are changes in V increasing or decreasing? So you can answer these 2 questions for quadrant 2, for quadrant 3, and for quadrant 4. So maybe if I see how this looks. Okay, so yeah, it's too fast. Try that. Okay, so you can use this animation then to help you, and I'm showing you the changes for every pi over 8 increase in angle. On the right, so that you can answer, so it helps you answer these questions. I'm going to slow it down even more. Okay, and I've got some stuff to hand back.
It's getting more negative.
Everyone talk about it. Ahmed. Pierce. I'm coming. Bring it on up. Okay, so we did the first quadrant. Second quadrant. Here we go. So second quadrant is through here. Is V increasing or decreasing? Decreasing, going down, right? And it decreases from what to what? Starting at, what's the value of V right in here? 1, ending at 0, okay? That vertical distance. The changes, if we look over here to the right, are those changes, so those changes are negative changes? Are they getting more or less negative? More negative, so therefore the changes are more negative changes, right? So this first is a little negative change, then a little bigger negative change, then the biggest negative change is at the end. When the changes get more negative, are those changes increasing or decreasing? In or D? D. This is that hard thing that we've worked on, and we'll just keep working on it. Decreasing. Because the changes are negative, they're getting more negative. It's just like the opposite of what you think, because you see bigger changes, but they're bigger negative changes, so they're decreasing changes. Okay, so the rate of change is increasing or decreasing in the second quadrant? Decreasing. It does. The rate of change does the same thing that changes. So with it, the changes are getting more negative. So because they're getting more negative, that's decreasing changes, and so that's a decreasing rate of change, and it's still concave down. Concave down. Decreasing rate of change is concave down. Third quadrant. Is V increasing or decreasing? Please.
Okay, so in the first quadrant, if the change there is decreasing.
That's right.
So wouldn't it be the same concept for the second quadrant?
Yes.
The same thing, just symmetry.
Right. But see here, the changes are getting less positive, so they're decreasing, but then they're getting more negative, so they're still decreasing.
So it's more positive and more negative, right?
No, the changes in the first quadrant are getting less positive. And then in the second quadrant, the changes get more negative. So all of that is decreasing. All of that is decreasing changes, or decreasing rate of change. Does that answer it? So watch this list of numbers. 10, 8, 6, 2, 0, -3, -7, -10. Do you see that is a decreasing list of numbers the whole way through? That's a decreasing list from start to finish, leading less positive and more negative. Those numbers continue to decrease the whole way. That's exactly what's happening with the changes. We have the biggest positive change at first, then we have smaller and smaller positive changes in the first quadrant. Well, then the change becomes negative. We have the smallest negative change, and then larger and larger negative changes. Those changes are decreasing the whole way. So this is decreasing the whole way. Does it help? Does it make sense? And because the changes or the rate of change is decreasing, it's concave down the whole way, concave down. Okay, next part. Third quadrant. V is increasing or decreasing? V, the vertical height. Going down, decreasing. Okay, the quantity itself is decreasing. What about the changes? Okay, these are negative changes. Are they getting more or less negative? Less negative. The biggest negative change is at first. And then we have smaller and smaller negative changes. So if those changes are getting less negative, are those changes increasing or decreasing? Increasing changes. Because they're getting less negative. Okay? So what will the graph look like? Increasing changes or increasing rate of change is concave. Up or down? Up. Watch it. So the quantity is decreasing, but it's concave up, meaning the rate of change is increasing. Last quadrant. The easiest one. Is V going up or down? Up. Are the changes getting more or less positive? More positive. Smallest positive change is going to be first, then larger and larger positive changes. So we're going to be, V is going to be increasing. And the changes are increasing. So that's going up, concave up. So there's one rotation of these two quantities taken together. So the x-axis is the measure of our angle swept counterclockwise around the circle. That's the x-axis. So let's label it. What's this angle right here on the x-axis in radians? Where the vertical distance has its maximum. What angle is that? Pi over 2. Where does the vertical distance return to 0? Pi. Where does it have its minimum? 1.5 pi, 3 pi over 2. And where does the vertical distance then returns to 0 at? 2 pi. Okay, so this is our input quantity, the angle swept measure of the angle swept counterclockwise from 3 o'clock. All right, and then our vertical axis is showing that vertical distance as a fraction of a radius length. So what's this highest vertical distance? As a fraction of a radius length, it's 1. And what's the lowest vertical distance above? As a fraction of the radius, -1. Okay, so this, by using fraction of a radius then, we talked about this as the unit circle, then this can be any circle. So this circle is 2.6 feet in radius. But it could be a huge circle. It could be a circle that's 100 miles in radius, or a really small circle. And these numbers don't change, right? The fraction of the radius length is still 1 here, no matter how big or small the circle is. And as a fraction of the radius, this is still -1 down here. So it can be the fan, or it can be any circle in the universe that will have this same relationship of the values of measure of the angle and vertical distance as a fraction of the radius length. So this is universal and special, this relationship. So it has a special name. So as a function, we can say f of theta. Theta is our input angle measure. And so as a universal special relationship, they give it the name sine. That's what sine is. The input is the measure of the angle swept counterclockwise from 3 o'clock. The output is the vertical distance above the horizontal diameter as a fraction of the radius length. And so since we're using that fraction of radius length, this works for all circles. Universal. So this is what's called the sine. So when understanding the sine means what? It means understanding what its input quantity is and what its output quantity is. So we're going to memorize those words until it starts to, we got to memorize it first, but then we're constantly working on the meaning of understanding it. Anybody have a question? Okay, so now we're gonna do the horizontal distance to the right of the vertical diameter. Let's set that up. And you're gonna do the same thing. All 4 quadrants. I'm going to keep handing back some quizzes. So we're going to do it for all 4 quadrants. What's the first question? So we'll call this quantity h, the horizontal distance. Let's write this down here. So now we're doing the horizontal distance right of the vertical diameter. Horizontal distance right of vertical diameter. Again, as fraction of a radius length. And we'll call that h. We'll call that h. And so, again, your questions are, is h, in each quadrant, is h increasing or decreasing? 2, are changes in h increasing or decreasing? And remember that, so that's the same thing as asking what the rate of change is doing. And that will determine whether the graph there is concave up or concave down. So I'm representing h by this red line here, the horizontal distance from the bug to the vertical diameter. And then up here at the top, it's not perfect, but I think you can figure it out. The red dots are showing you for each pi over 8 measure of the angle what the change would be. Okay, go. All 4 quadrants. So there should be 25 conversations going on right now. Aja. Shannon here? No Shannon? Darwish? Please. Alexandra? No, it's not. Alexandra. Okay, first quadrant. H increasing or decreasing? H. The horizontal distance right of the vertical diameter. Increasing or decreasing? Decreasing from what to what? It starts at 1 and ends at, in the first quadrant, it starts at 1. 1 radius to the right, and then after pi over 2, it's at 0. So those now the changes. Changes are positive or negative? Negative changes. Getting more or less negative? More negative. Are those in or decreasing changes? In or D? Decreasing. Good. Got it. These are decreasing changes because they're negative changes getting more negative. Negative changes getting more negative. Decreasing changes. Okay? What does that look like? From 1 to 0, concave down. So this is a little trickier because now the horizontal position we're graphing on the vertical axis. Okay? So this vertical axis now is tracking horizontal position, this quantity h. So this is a little trickier to see it. But just remember, what happened to the axes? The horizontal axis is still the angle, measure, and radians. But now our vertical axis on this graph is tracking horizontal position this way on the circle. Yes, sir?
Okay, so we keep saying that it's more negative. Show me exactly what is more negative. What's more?
The changes. The changes. So with each angle, measure.
Like, can you,
Yeah, I'm about to do that. Here's the first negative change from there to there. Here's the second negative change from there to there. As the bug, you got to imagine the bug traversing this quadrant here. So first change is right there, up at the top on the arrow.
So those changes look bigger to me.
Right, but they're negative changes. So bigger negative numbers, like this. First little change, say -1. Next change, say -3.
So is it safe to say that if you just go left, that's negative?
The
Going
change.
left is negative. If you go right, it's positive.
What's it? There are two quantities. There's h and there's changes in h. We're looking at those separately. So when you say it, we need to distinguish between which quantity you're talking about. So
Okay, so I feel comfortable with h. I get that h is decreasing. That's pretty obvious.
From one,
that's good.
from one,
But what I'm talking about the changes.
right?
The changes increasing and decreasing. That's the part that throws me.
Okay.
How can you tell if the change itself is increasing or decreasing?
Okay, so here's, for this particular case, these changes are negative changes because I think what you were saying was, because the bug is moving left, therefore the changes are negative.
How do you know that it's negative?
Okay? Let me just do, I'll show all of them at the top of the circle. So from here to here was the first change. Since it's a left change and the positive is to the right, that's a negative change. Final minus initial. Change in a quantity is, so the change in h is going to be the final h minus initial h, back from week 1. So the final h is here and the initial h is here. That's going to be that's going to be less than 0. Because the final h is a greater positive value than the initial h. The initial h is a greater positive value. Final h is less positive. So when you subtract, you're going to get less than 0. So that's a negative change.
Thank you. That's what I needed.
And then, so these are negative changes, and they're getting bigger negative. So that's like this list of numbers right here. So is that increasing or a decreasing list of numbers? Increasing or decreasing? Decreasing.
Okay, got it.
Sweet.
To cover what we just went over, so quadrant 1 is decrease, increase, and more negative.
Whoa, what?
With quadrant 1,
H, so H goes from, the starting value of H is 1, final value of H is 0. So H is decreasing from 1 to 0. The changes are decreasing because they're getting more negative. These are negative changes
okay,
getting more negative.
so decreasing more negative.
Right.
I guess I just think like this inside, yeah, like it's even bigger.
Right. That's and we've been fighting this for a month, right? This is this fight we have. It's hard when the changes are negative. It's opposite what you think. Yeah, this is the same thing we've gone over and over and over again, and it's hard. It takes a while to stick.
So it's like I have to put things in numbers. So is it decreasing because it's going from the changes to because going from 1 to 0, or the changes in H like?
No, the changes in H don't have to do with the fact that we're going from 1 to 0. So 1 to 0 is H. H starts at 1 and ends at 0. That's H. So it's decreasing. Heading left. Now, because we're heading left, those changes are negative changes. So you see, I'm showing arrows here, negative changes. Are those changes getting more negative or less negative?
More negative.
More negative. Numbers that...
Like any numbers on like, there's like that type of graph that can like show that? Or
What's that?
It's like, is there any type of numbers that can show that besides like a list?
Yeah, I mean, we don't... Not quite yet. Not quite yet. But this is the idea of it. Suppose this little change here was -1. This one's -3. This one's -5. And this one's -7. That's the idea. But that's not those aren't the right values. It's just the idea of it. So those are decreasing changes. But see, so then the rate of change is decreasing. That's why it's concave down. So concave down, the shape of the graph, reflects that the rate of change is decreasing. Okay, next quadrant. No, this is great because it feels like you guys really want to get it. That's great. So next quadrant, H, decreasing or increasing? So in the second quadrant, is H increasing or decreasing? From what to what? 0 here to -1. The changes, are they negative or positive changes? Negative changes, getting more or less negative? Less negative, so in or decreasing changes? Increasing changes. They're getting less negative. Less negative. So H goes from 0 to -1, so H is decreasing. End of story. Changes are negative changes. Why? Because we're heading to the left. But those changes are getting less negative. So it's like in my number scale, it's like going this way. If you go this way, that's increasing values. So what will the graph look like? It will go from 0 to -1 and be concave up or concave down? Concave up. Like that. So from 0 to 1, so the vertical coordinate from 0 to 1, concave up because those changes are getting less negative, so they're increasing changes. Third quadrant. H increasing or decreasing? H is increasing from what to what? -1 to 0. -1 to 0. Okay? So, and then the changes. So imagine going this way. Those are positive changes now. Positive changes. Sorry. Positive changes. Sorry, this way. Getting more or less positive? More positive. That's easy, right? More positive means the changes are increasing, concave up. Concave up. So H goes from -1 to 0. Here it is, -1 to 0. Changes are increasing, getting more positive. So concave up. Last quadrant. H goes from what to what? 0 to 1. So it's going to be 0 to 1. So the question is, the changes getting more or less positive? Less positive this way. Increasing or decreasing changes? Less positive. Decreasing. Concave down. Okay, so this is now the second relationship. Second relationship here between these two quantities, again, it's universal. We'll call it G. Input is the measure of the angle swept counterclockwise from 3 o'clock. Output, horizontal distance right of the vertical as a fraction of the radius length. And so we call, it starts at its max at 1. When we get to an angle measure of pi, it's at its minimum of -1. That's over here. So again, this is universal. All circles have this relationship if you're tracking the horizontal distance as a fraction of the radius length. So this one is called cosine, C-O-S. Again, same for all circles. Universal. Please.
Is cosine, does that mean like you're tracking horizontal movement?
Yes, right.
And what was the first one we said?
Vertical distance above the horizontal diameter.
Okay, what's that one called?
Sine, and it's S-I-N. S-I-N, it stands for sine. That's right. Okay, so if we want to talk about now if we want to talk about the fan, we said this was in fraction of a radius, this value is 1. As fraction of a radius, the least value is -1. But what if we want to talk about the fan, and instead we want the horizontal distance as in feet? So what was our radius of our fan? It was 2.6 feet. So then, what would the maximum distance in feet be? 2.6. And the minimum distance? Down here. -2.6. And so if we wanted to write a function, say h, now, whose input was the angle measure, but the output was the horizontal distance in feet, what do we do? So we've got the number of feet of one radius is 2.6, and we know that we got the horizontal distance as a fraction of the radius. So what would the function be to have the output be in feet instead of fraction of a radius? Should be apparent. All these horizontal distances are what compared to fraction of a radius? So what are they in feet compared to a fraction of a radius? Multiplied by 2.6. We'll take every fraction of the radius that we have. If we multiply it by 2.6, it'll give us feet. So to get that function, we'll take 2.6 times cosine theta. And that will output, for this bug, on this fan, it will output its horizontal distance in feet. Okay, and if we wanted, so that would be so everything would be the same, but now instead of fraction of a radius length, the output of h would be giving us the horizontal distance in feet instead of fraction of a radius length. So we can do that the same thing with the what will the output of this function give? 2.6 sine theta. Vertical distance, vertical distance above the horizontal diameter in feet. So cosine and sine track everything in fraction of a radius length. If you've got your radius, all you need to do is multiply by your radius in whatever unit it's in, miles, feet, inches, centimeters, and then you'll be tracking those distances, horizontal and vertical, in that unit. So so the cosine takes whatever fraction of 2.6. Sine will take whatever fraction we need of 2.6. Multiplying. Okay, so let's look at I want to talk about theta is 5.2 radians. Can you estimate where, if this fan turns 5.2 radians, can you estimate where the bug will end up? Should be able to. So let's just start with quadrant. What quadrant will the bug end up in? It's 5.2 radians. Okay, remember 3 was about here, right? Because pi is halfway. So 4 is down here somewhere, and 5 is just past there, and then 6 is like here. So 5.2 radians is going to be right here. There's 5.2 radians. So what I want you to do is I want you to estimate the value of the sine of 5.2 and estimate the value of the cosine, understanding what those functions do, right? They take an angle measure and you review what do they do, and then so based on that, estimate it. So we want the sine of 5.2 approximately, just eyeballing. No calculator. No calculator. This is to see if we understand what sine and cosine are. So see if you can estimate the sine of 5.2 and the cosine of 5.2, which of course associates with the bug being right there on the circle. Can you estimate them? Go, give it a shot, and talk about it. No calculator. We're estimating based on the meaning of sine and cosine. No, this is the value of the sine and the value of the cosine. What is sine? Sine is the vertical distance above the horizontal diameter as a fraction of the radius length. So what would you estimate that to be right here? Okay, let's see how we did. So how about Taylor? Do you have an estimate for sine of 5.2? Okay, so what is the sine? What does the sine mean? The output of sine is what? Measured in? Nope. Radians is angle measure. So how are we measuring that vertical distance? As a fraction of the radius length. Okay? So am I going to look at this line right here or this line right here? First or second? 1 or 2? If I'm talking about sine. Vertical distance above horizontal diameter. This one. Now we want to measure what fraction of a radius length would you estimate that to be? That's the value of the sine, the fraction of the radius that is right there. So is it a tenth of a radius? Is it half a radius? Is it 3/4 of a radius? What would you say? 80%. Yeah, 80%. So therefore the value is, as a fraction, negative. First of all, it's below, so negative what? 80% is what fraction? Negative 0.8. Who came up with something like that before we started talking? Okay, yeah, so the sine, you'd estimate the sine to be about negative 0.8 or even negative 0.9, somewhere in there. We're almost a full radius below, but not quite. So 0.8, 0.9, like that, and it's negative because we're below. Does it make sense? Okay, how about cosine of 5.2? Now we're talking about what? Horizontal distance as a fraction of radius length. What would you estimate it to be? First of all, positive or negative? Positive. Positive what? 0.2? 0.6? No, it's not. 0.6 is more than halfway. Is that more than halfway? No, but we're just estimating to see if you get it. These are estimates to see if you understand. 0.6 would not be a good response here. 0.6 is further than halfway. 0.4, 0.5, something like that. 0.4. Forget what you've learned in the past. It's a hindrance. Okay? If you've learned trig before, try to start over. Okay? All these facts you memorized can get in the way. All right? So, yeah, 0.4, 0.5, something like that. And it's positive because we're truly to the right. Truly to the right. So 0.4 of a radius length. Does it make sense? Where did I lose you? Okay, well, if you can ask a specific question. What's that?
It's like your 0.4 of the way to 1.
Yeah, so looking horizontally, this distance from here to here is 1 radius length.
Okay.
So we're asking what fraction of the way is the bug to 1?
Okay, and then that's why it's 0.8.
Vertically, 0.8 is almost to the bottom, almost to 1.
It's negative.
Negative because it's down, and then almost there. So you could have said 0.8 or 0.9 like that.
Okay.
This one would be 0.4 or a little, just under 0.5. Okay, let's try another one. Okay, how about, let's just do cosine and sine of 4. So what does 4 represent? What kind of quantity? What's the input into these functions? Measure the angle. So, where is 4 radians? Third quadrant. It is right here. Okay, go. So you estimate cosine and sine of 4, which is where the bug is right now. Estimate the cosine and sine of 4. And talk about it. Tyler. Andy. King. Cassidy. Is it good? Just way over there. Jessica. Jessica? Justin. All the way down to Justin, please. Cosine of 4. Approximately what? Cosine of 4. Estimate. What do we think? Melise. Negative 0.7? What do you think of her estimate?
Yeah.
Decent, yeah. 0.6 or 0.7? Negative 0.6, 0.7, right in there. Just past halfway. Sine of 4. Let's compare it to cosine, and let's go off of what we did for cosine. So is it more of a radius or less of a radius than the cosine? More, right? More. So let's do negative 0. What? 8. Fine. Getting the idea. Or we could have done 0.6, negative 0.7. Doesn't make sense. They're both negative. Why? Because cosine we're to the left of the vertical diameter. Sine because we're below the horizontal diameter. And this is the fraction. We're estimating the fraction of a radius that we are. Okay, so notice that what we said was 0.7. Isn't that this distance right here? Negative 0.7. So if this is like a graph, right? Like if this is the y-axis and this is the x-axis, what is that negative 0.7? What is that like for this point? Yeah, it's like x-coordinate, right? And then that negative 0.8 would be like this right here. What would that be? Why? Okay, and so this is another kind of way to think about cosine and sine. So this was which one? Cosine or sine? Another way besides vertical and horizontal distance is to think of them as x and y coordinate. So cosine is the x coordinate on the unit circle, which we said has a radius of 1, right? Radius of 1. So this is x coordinate. And the sine is y coordinate. Okay, so now if this was the fan and we wanted to know how many feet the bug was to the left and how many feet down, could you find it? So remember, the radius of the fan was 2.6 feet. So estimate how many feet to the left is the bug and how many feet below the horizontal diameter is the bug. What would you do? Yeah, this is a whole radius, and we've got these convenient numbers that are a fraction of a radius. Then what would we want? We would want 0.7 of 2.6. That would be how many feet to the left he is. She, ladybug, right? So what would that be in feet? So take 2.6, and we're going to take that fraction of 2.6. 2.6 times 0.7. Tell me, as soon as you get it.
Negative 1.82.
1.82. Do you see? Feet now. This is feet. Okay? And then, how many feet below the horizontal diameter is the bug? Based on our estimate of the fraction of the radius of 0.8. Negative. Oh. Thank you. So by doing it as fraction of a radius length, it's very convenient because then we can apply any circle and we can get the coordinates in whatever unit we're measuring the radius in. Feet, inches, miles, centimeters. Okay, so this is what sine and cosine are about. They're about an input quantity of angle measure of an angle swept counterclockwise from 3 o'clock. The output of sine then is the vertical distance above the horizontal diameter measured as a fraction of the radius. The cosine then, its output is the horizontal distance to the right of the vertical diameter as a fraction of the radius. So let's take a look at, so here is a, for not for this week's quiz, but for next week's quiz and probably the one after that, you're going to be filling out a chart just like this. In all specifics required. So see if you can do it without looking at your notes. See if you can do it without looking at your notes. Write out the input of sine, all the details. Write out the output of sine, and what coordinate is on the unit circle. Same thing with cosine. Write out the input, write out the output, and unit circle coordinates. So just practice right now without looking at your notes. Practice writing these out. We're going to memorize them. We're going to memorize these input and output quantities of sine and cosine. Not here. Okay, so here we go. Input of sine is measure of the angle swept counterclockwise from 3 o'clock. We can use any angle measure. We've been using radians, but any angle measure is okay for that. Output, vertical distance above the horizontal diameter as a fraction of radius length. Okay, all the details are important. They're all worth points on your quiz. But the reason I'm making you memorize it is that when you come to problems, you're thinking in this way. You're applying these ideas, these meanings to solve problems. Okay? Unit circle coordinate of sine is, if it's vertical distance above horizontal diameter, then what coordinate is that? That's the y coordinate, right? Cosine, what's the input? Same as sine, exactly the same angle. Measure of the angle swept counterclockwise from 3 o'clock. Now the output is, for cosine, horizontal distance to the right of the vertical diameter is a fraction of the radius. Okay? Unit circle coordinate, x. So let's practice one more time. So in this picture that I'm giving you there, I'll try to draw the circle. Estimate the values of sine and cosine shown there. Well, let's estimate the angle in radians first, and then estimate the values of sine and cosine. And I'll try to sketch the circle here to help you. Something like that. Estimate the angle in radians, estimate the values of sine and cosine. Give you a little hint on the angle there. Okay, and then talk about it. Compare your results with the person next to you. For the angle, what you think the angle is, and what you think the value of the sine cosine is. No calculators. This is all estimating. Where's Araceli? Araceli here? Daniel.
What's the reason?
So the only thing that left out
Angle. Estimate the angle in radians. What do you think? Angle measure in radians. Christopher, what do you think? Angle. What did you think what the angle measure was in radians? 2.2. That was my guess too. Do you see that it's about 1/5 of the way from 2 to 3? Perfect. So 2.2. All right. Now estimate the cosine. We'll do sine first. Estimate the sine. What do you think? What do you guys think over here? Tell me your name again. Yeah. No, yes, you.
Oh,
Nancy, tell me what did you estimate for the sine? So we're estimating the sine of 2.2. 0.8. Positive or negative? Positive 0.8. What do you guys think? I like it. It's about 0.8 of the way up to the 1 full radius. Okay, cosine of 2.2. This side. Adam, what do you think?
I said
Negative
negative 0.5.
0.5.
Negative 0.
I like it. It's about halfway. It's about maybe a little bit more, but 0.5 is a great estimate. To the left. Okay, so now I want you to get your calculator out. And make sure it's set for radians. So if you go mode, get your calculator, hit mode, and make sure it's set on radians. Which selection is that down from the top? The third one down?
Yes, normal flow radius.
So go down to the third one and make sure radians is selected. Then go back to the main screen. And we're going to put in sine of 2.2 and see how we did. Put in sine of 2.2. What does it say? 0.8 what? There it is, 0.80, right? It's telling you the fraction of a radius that you are above the horizontal diameter. That's what that number is telling you. Put in cosine of 2.2. Negative 0.59, so 0.6. And we see that's a little bit further, right? It's a little bit further than halfway. 0.5 is a good estimate, negative 0.5 is a good estimate, but we can see that it's a little further, negative 0.6. That's what the cosine is telling you. As a fraction of a radius length, how far you are to the right of the vertical diameter. This is what trig is about. Okay, we'll have web work for Thursday. And the quiz is already posted. Thursday's quiz is already posted.